All right, 3x pitch biometrics here of Nick. We're going to pair him up with the legend Alhan and Miller.
Hey Nick, it's August.
We've got Al here at 91, and we've got Nick here at 84.6. We are looking at lefty to righty. The reason I picked Al is because both you guys remind me of each other. Al's bigger. What did y'all remember Nick's height? Steve, you remember Nick's height?
I think he's like 6'1" or 6'2".
Yeah, like 6'1", 6'2". Al's what, like 6'3"?
6'3", 6'4".
Yeah, he's 6.
I think he's 6'4".
He's 6'4", yeah. So Al's going to be bigger, way more. So ideally, you'd have to be moving faster than him. Because we're using, righty lefties, we'll be following these kind of mirroring each other. 240 frames per second, 144 frames to front foot strike where y'all are right here. We're going to be looking at everything's in inches, speed is inches per frame. The distance from the origin is going to be the back foot on the rubber. Everything's being measured from that origin, every joint. And X, Y position, X is just the horizontal measurement from that origin, and Y is the vertical. So we're going to be following Al's right side and your left side. So let's go. We're going to go 8 frames per click initially to keep it moving. So let's go 48 frames. So we got Nick here. His left hip is 14 inches from the rubber. With the lefties, anything left of the origin is going to be a minus, so you can just ignore the minus. So 14, and Al's at 17. So Al's got he's a little ahead of you. He's pretty comes out with a lot of momentum. Good falling forward and down pretty well. It looks like he might even be lower to the ground. He's 36 inches from the rubber, and you're 38, so he's 2 inches lower to the ground. So he's already sitting at this point. Let's go another 6 clicks, 96 frames. Here you can see similar on the arm cocking. You're already open at this point. He's still closed. Your left hip is 20 to his right 25, so he's 5 inches ahead of you at this point. You're 32 inches to the ground. He's 29. He's lower than you. Definitely more linear back legs. So a lot more momentum. And now at this point going forward, if we look at that force vector, I go really to the middle of the hip back to say that ankle. I don't want to do it this way. Sorry. Actually, yeah, I got to do it straight here. If I go straight, try to go parallel to the ground, and then up to somewhere in that middle of that hip, I'm at 42 inches or 42 degrees. We look at you, we'll have somewhere in the middle of this hip to this ankle. So you can see you're at, it's like 55. Yep, 55 degrees. Okay. Go from here, we're going to follow your knees. We want to see how much linear speed you're pushing off that rubber towards the target. So we're going to look at, go 1 frame per click. We want to see where it peaks, how high it peaks. So I was already at 4.5, a lot of energy at this point. And then he's slowing down. So he peaked pretty early. Peaks at a 5.7 right here. Let's see where you peak. So you're later, which is good, and you're peaking actually a lot higher. Okay. So I mean, it's a different approach. I think this is where Al can also continue to improve. Al, I think it's a lot of his is coming off of momentum. So he gets his momentum going earlier than you. So that's what gave him the peak of speeds a little bit earlier. I think you're not nearly doing as well as generate the momentum as Al, but you are doing a good job of getting extension at that point. It comes down to force. And once again, like, he weighs a lot more than you, so you should be moving faster than him. But it comes down to how much force is going to hit front foot. With all that added momentum, with more mass, he potentially is going to be hitting with more force. We'll look at the stride length, what is produced here, but you definitely are driving more than him, it looks like, at this point. Okay. So at front foot strike, your stride length it goes 75 inches. If we watch him, you can tell it's not as much drive because you're slowing down at that knee at this point. So at front foot strike, he gets to, if we look at his 98 inches, so crazy long stride. So, momentum's just really a great way to generate a stride length. With Al, you could even say, with him it might be too much because we don't see that peak of knee speeds, which if Al could bring in peak and knee speeds going into front foot strike, what we would probably see is a more open hip position at front foot strike. So there's still kind of not enough power, or Al could still get more power into front foot, a considerably amount more power, or later into front foot, which would significantly correlate to his velocity. So you can see when you hit, your hips are actually more open. You're in a shorter stride, but your hips are more open because you peaked forces later. You had more drive, therefore correlated to more hip rotation. Okay. So let's look at the hips. Let's see how those hips peaked. Okay, so it looks like they peaked into front foot, but you can see it's still peaking after. So a little late with generating energy. So it's not too bad. But your hip speeds came after front foot pretty significantly. Let's see where his hip speeds peak. His are still going too. So that's another thing. Al's hips were late, a lot more later than yours. So Al's just beating you on more momentum over a longer stride, hitting front foot, but not peaking back leg late, or peaking back leg late in the front foot, peaking hip rotation late. Al could do that better, but still he has just a lot more momentum. So you're doing a little bit better on those lines. Which is what's happening is he's at the point of hip speeds peaking, you have more hip to shoulder separation than he does. So if we go into the front views, remember the front views, the origin's down the middle of the back foot. Anything in the X position to the left is negative, anything to the right is positive. So if we go to front foot strike, we can see you're landing open. So your right toe is 2 inches to the left of the origin, so you're landing pretty open. If we take Al to front foot strike, he's landing on the left toe 14 inches, so he's a lot more closed than you. He's actually a little bit maybe too closed, and you're actually too open at this point. If we look at hip to shoulder separation, if we look at your left hip, it's at a 5 to the right of the origin, to your shoulder, which is at a 3. So there's only about 2 inches of separation between your hips and shoulders. If we look at Al at front foot strike, and this is at front foot strike, which we're not looking when the hip speeds peak, which is important, but we're not looking at it right now. We're looking at this position, front foot. Al's right hip is -14 to the left of the origin, and then the shoulder is -7. So there's a 7 inches of separation. Not really great for both, but definitely he has more than you. As far as shoulder orientation, yours left shoulder is a 3 to the right of the origin, and your right shoulder is a -1. So you have an open shoulder orientation. He, at front foot strike, right shoulder is a -7 to the right of the origin, or actually to the left of the origin, and then the left shoulder is a -7 as well. So he has pretty much, it's just a perfectly aligned orientation. So we want a closed orientation. We want more hip to shoulder separation. So he's got a closed or an in line or slightly closed orientation, more hip to shoulder separation. You have a more open shoulder orientation. More than likely, this is the benefits of landing in a more closed front leg position. You're going to have a more closed shoulder orientation. You're in a more open position, so you have an open shoulder orientation. It's just harder to land closed when your front side is open or your shoulder's closed. So he's got you beat there. As far as contralateral tilt, y'all pretty much look the same. Pretty vertical. As y'all go to shoulder rotation, you can see Al. Let's see what he gets on contralateral tilt. About 10 degrees. Let's see what you get. On the vertical plane, you have about 3. So he's got a little more contralateral tilt than you. So that's going to correlate to more ball speed. His elbow is a little low, which is the only negative I have with his arm slot. Yours is actually not too bad. Okay. If we go back to front foot strike, if we watch the chin, let's see how that energy transfers forward. Actually, let's look at the front leg stabilize it. So right knee for you, left knee for him. He's 80 inches from the rubber. His drifts 2 inches, 3 inches, and then comes back 1. So drifts 3 inches, comes back 1. Yours drifts 1 inch, comes back 3 or 2. Drifts 1 inch and came back 2. Okay, so you had a better front leg, but he had a way longer strut. From here, let's see how well this went forward. So let's see, counting from front foot strike, look at the chin, see how it goes forward after front foot strike. We're going to look at the speed and the distance. Yours is 46 inches from the rubber, 0.7 seconds, or 0.7 frames, or inches per frame. So you 0.7, you stay up to a 6, drop to 5 a little bit, and you went to a 64. So that's 18 inches. He's 62 and going 0.8, so his trunk's going faster and slows down a little bit more than you, but had higher speeds initially. It was 62 right to 85, so that's 23 inches. Was it 62? It's 23 inches. Yep, 62 to 85 is 23 inches. So really great trunk. More trunk distance, a little bit more trunk speed, and then I think the arm pass is going to be important with both you guys. Both of y'all are more 3/4 arm slots. We look at front foot strike. We're going to watch that right shoulder, see where it peaks. Okay, 1.6 or 1.59. Your left shoulder hits a 1.4. Okay, you're close. Elbow hits a 3.5. His elbow hits a, okay, your elbow's faster. This is a 1.8, and then wrist hits a 5. It's one of the fastest arm speeds I've seen in a long time. Yours hits a, okay, 4.3. Okay. So the thing too I wanted to look at is arm path And look at your trunk orientation too. Let's look at this. So if we follow trunk orientation, let's see, chin to hip to ground, you're at 66 degrees. Let's look at his. Ground to hip to trunk. He's at 57, so almost 10 degrees more of forward trunk tilt. That's significant, you know. Plus, we saw more trunk distance traveled. If we look at that arm path, because I see an issue in your arm path. Let's see. You can see when he comes into arm cocking and hits front foot strike, you see the arm still moving in the cock position, and then as he goes into shoulder rotation, that arm doesn't stall out too long as it lays back into external rotation because that trunk continues to move energy forward. You can see when you're coming out, or you're coming into front foot strike, your arm is going into a more flexed position, it looks like, a little bit more as it cocks. And then when it lays back, it gets really caught and delayed, or actually it starts the delay, and what you do is you start pushing it through that movement and not so much the trunk going forward. So from here to here is pretty much a significant difference for you, and this is more than likely too why his arm speed, trunk speeds went farther, and his arm and faster, and his arm speeds also jumped up as well. At this point from here, you can see the trunk is continuing to move forward, and the arm is transferring. Well, I would say it's moving forward. You can see the arm is, as the arm's abducting, it's laying back, and then it's quickly turning over. When you hit this position, your trunk isn't moving forward as well, and your elbow's pushing ahead and then turn over. So it's just the fact of your trunk didn't move as much forward, didn't move as far as in degrees into a more linear position, which would have allowed your arm to want to turn over without any horizontal adduction or pushing in front of the face. So the point is you have a little bit more delay here than he does. His arm better transfers his kinetic energy is what I'm saying. So when his arm lays back, it just continues to move pretty efficiently with the trunk and isn't being pushed. I just see you pushing your arm, which to me is a slight little break in the kinetic chain, and you're trying to overcompensating for that lack of trunk energy going forward. So I just saw that in you as being a little disturbance in your energy. I think it goes all the way down the chain to you not getting as much momentum, hitting front foot strike, and not carrying your trunk as well. You're not separating as well because not as enough momentum. There's a lot of things that Al really can improve on. He's just getting more energy into front foot. That's carrying more energy forward, and he's separating well to allow that arm path to release that energy at the end. You don't have that energy and separation, so your arm is overcompensating at the end. But at the end of the day, it's just he's bigger, he's moving a lot faster across the board when we looked at all the measurements.